and I would like to give you a short introduction of our speaker and what our activities here is all about. So we started last October in 2023 with the Automation Research Summit, and we invited basically all our research partners, and some around 20 attended the first time. So we have around 100 globally, and our goal is really to build this community, building a community of people who want to exchange their knowledge. And we are in a very small niche industrial metrology world, where automation is becoming more and more important. So our idea is to bring, and in UK they name it catapult. So we have basic research, basic research. We have basically research, but fun, which we want to connect with integrators, and then the end customer has a fully dedicated solution which is solving their problem. So based around Hexagon technology, we were holding this research summit, and everyone had a 5 minutes introduction. And with this introduction, we formed the first online community. And now we continued, I think, with number 5 or 6 deep dive session. And the next deep dive session is held by Argon, one of the integrators who are using our technology and has links, and also developed further really a solution. Here we can see for the wind energy. Our speaker today is Gert Kremers. He holds a master degree in mechanical engineering, economics, and philosophy, and he is the founder of Argon, who is a partner over many years already for Hexagon. I think almost 10 years soon. And with that saying, I would like to warmly welcome Gert and give you then the stage. I just wanted to mention, if you have any questions, and there is time for questions at the end, please don't hesitate to put them in the Q&A section, and we will ask this at the end of this presentation. That's it from my side, and I will go mute and silent, and Gert, the stage is yours.
Before you go mute and silent, is it 45 minutes? So what was or 50 minutes, or what is
50 minutes, and then we have 10 minutes Q&A.
Okay, fine. Okay,
but good. Plus minus, we have some room to fill.
Okay, very good. Okay. Yep. Okay. Thank you, everybody. Good morning or good afternoon for some. A warm welcome to this webinar. And I'm going to talk about shop floor measurement solutions for the wind industry, and give you a sense of what we have been developing and what we are developing over the last years and towards the future. And it's all about matching size and precision in this industry. So I'm going to give you a short introduction, and then very importantly, I'm going to talk about the market evolution and the value of matching size and precision. It's all about shop floor. It's all about informing, inspiring, engaging the shop floor, giving you also a sense of how we are achieving that. And then very concretely zooming in on specific applications that we have developed for the various components of that industry, from blades to nacelles to towers and foundations and cranes. So let me start by giving you a very brief overview of Argon in a nutshell. So we are a niche metrology services and solutions provider. I founded the company in 2004, almost about 20 years ago. And I'm very proud to say that actually last year we have created an Argon 2.0. I have created a new management from people that came from within the company. We have done a management buyout. And we are actually a new company. We are quite small, 21 people, 4.2 million euro last year, which represented a 30% growth. And we are compared to what we did in the past, we are very, very focused now. And our focus is really on large scale metrology, and particularly also the wind sector is a prime focus of us. And also in terms of partnerships, we are focusing on Hexagon as a prime partner. Okay, so we have a list of customers historically built up. But you could say there's wind customers, transport, aero, bus, truck, rail, energy. And the top section here of customers, we have developed this line. This area was empty 4 years ago. So really we have found a niche area, a focus in wind, and that is paying off for us and giving us very nice growth opportunities. So wind. What does it mean? What are the evolutions there, and why are measurements so important in the wind sector? Basically, because everything becomes larger and larger in wind, and the time to market becomes shorter. So they need to have the new generator next year rather than in a couple of years' time. So these are the time and the size are really the driving changes in this sector. Which means that every individual component is growing in size, from the towers, the foundations, to the nacelle, to the blades. What does it mean in terms of numbers? You're talking about 110 meters, 120 meters currently, going up to 150 meters in the next decade, but beyond 150 meters. The nacelle, a generator, direct drive generator. In the past 5 years ago, you had diameters of 4 meters. Now you are at 8 meters. They go to 10 meters, and it will still go beyond that. The towers and monopiles, there you talk about structures of 100 meters and then 70 meters below the sea level. You're sitting with diameters 8, 10 meters and going up to 12 meters. So these are gigantic structures. And you think, well, yes, if you see, well, how is this evolution going? So I took a graph here in 2019. The prediction was that by 2035 you would do a growth of the power by 3 times, times 3, and the size in terms of hub height and rotor diameter by 50 to 66% increase. And if you look in reality, you see that after 5 years, you have already almost 60 to 75% of this increase has been observed. You are sitting now at 14 megawatt turbines that are shipped out into the sea, installed into the sea from Siemens, whereas then they predicted 17 megawatt by 2035. The rotor diameter, you are sitting already at 190, 200 meters. And the hub height, you are sitting at 140 meters. So it is actually growing even faster than predicted even a couple of 5 years ago. So that presents enormous challenges. And really, despite the fact that you talk about 100 meters, even the millimeters do matter. It's a little bit as if you look at the watch of your look at the Swiss watch. There you have a 30 millimeter size, and it's the same is true as about talking in terms of microns for a watch. A watch is made with micron precision. At a similar scale, here you have 100 meter structures that are made on millimeter precision. And why is this important to millimeters? It's about turbine performance, about lifespan, maintenance cost, and production efficiency. We'll talk more about that later. So when you don't get these millimeters right, you will have bigger problems. And these small problems can become even bigger problems in the future. And it's, if you look at it, these wind turbines have the size of the Eiffel Tower. And it's really amazing to realize that geometry errors of 1 millimeter in certain key components can have really a non-negligible impact. So it's pretty amazing. And so we see that when you start manufacturing with higher precision, you bring these tolerances down to millimeter and below millimeter, you get an increased quality and an increased efficiency. The quality is about your turbine performance. You increase your annual energy production. You increase your lifespan, less vibrations, less fatigue, and that means also lower maintenance costs. Yeah. When it comes to producing these turbines, you can do that more efficient if you work more precise. That means you have less rework, you have a better cycle time because you do it first time right, and you have generally a shorter time to market. So that is the value of really focusing on getting more and more precise, finding these millimeters on 100 meter or sub-millimeters. So it means also that these traditional methods, and what you see here is not a joke. These are the methods that are currently most popular in use for this type of industry. At this moment, I'm in Aalborg in Denmark at the blade factory at Siemens, and I could not take pictures, of course, but yesterday a blade was glued. I had a lot of tape glued on the blade to measure with the roller tape the certain dimensions. So it's still going on. But these traditional methods to meet the challenges of the future, they will no longer be sufficient. Why? Well, have a look here. This is how flanges of a tower or a monopile transition piece used to be measured a couple of years ago. You see lots of people, I count about 7 people, ladder, very unsafe. Of course, you can imagine it's very slow, a limited amount of data. If the blue guy measures it or the white guy, the data will be different. So it's user dependent, limited accuracy. So they're not going to make it with this type of method. So you need new technologies, you need new tools. So that is where Hexagon comes in to develop these new tools. And the first such tool was released in 2019, the ATS 600. It's a new non-contact large-scale measurement device. And I call it's an automation. We're talking about automation, automated measurements. And this is automation without a robot, because robots cannot be used when you talk about 100-meter structures. So, of course, to give you a flavor of this, for those who are not familiar with the ATS 600, here is an advanced implementation, even on a mobile platform, autonomous and AGV platform. And you see it really can measure with a laser dot autonomously without the involvement of a human hand, and it can digitize surfaces in a quite a quick way. This example also shows that you can move it around in an automated way, and in that way ensure an automated accurate inspection of your parts on the workflow. So so you get your results. So you're fully digitizing your surface. So this gives you a flavor of these new technologies that are really autonomous laser beam technologies. So these technologies, it's good that they can measure autonomously. It's good that they can measure accurately, but also it's important to deliver the results quickly, in time, and also in a format that can be acted upon. So that's also quite important. So that means that this feedback loop or feed forward loop, the shortening of that loop is key. If you can ideally do it within the cycle time of the production, you create the most value. We see for customers, when we go to a customer, we immediately look at, okay, is it what we call a 3D inspection solution? Or is it a measurement assisted production solution? Because we know the client has much larger budget, has much more interest when it's really can become part and parcel of his production activities, so that the measurement results are really used immediately and are acted upon by a machine or an operator as part of the manufacturing process. So feedback time is critical. And of course, you have to do this all without robots. So you need, whatever you do, you have to get operators involved. You have to empower operators. It's a people's game. And to give you an idea how our Siemens Gamesa is currently our biggest customer, and how they also did communication about getting their operators involved, we show you this video. It is a video that was created, as a result, as part of our work for them, and this is how they communicated internally. Okay, so this gives you an example of how Siemens Gamesa, the work that we did for them, was a transformational work in terms of the way they are producing these generators, the way they are making use of measurement technology. In total, you were talking about an investment of about over 10 million, of which Argon and Cundabora, a local partner in Leuven, we delivered about 7.5 million euro over the past 5 years. So it's major work and major success for us, and it's really the philosophy of bringing, based on the philosophy of bringing measurement technology on the shop floor, and making sure that you get these operators involved, that the actions that they take are correct. And we have used the term making it as simple as making a coffee, using the system, making the use of the systems as simple as making a coffee. Really, it is very rewarding when you do these things, that you get the involvement of all the people, of the operators, of the maintenance persons, and you feel also that they start owning the system. And of course, it's all about, if you cannot see it, you cannot solve it, you cannot prevent it, you cannot improve it. A small anecdotal story that I can tell here is that in last year we did a project in Denmark, where a supplier of windmill towers was handling the towers with the hook, as they have been doing for the last 20 years. But because the towers are getting bigger and larger, suddenly plastic deformations started to come in because of the size and the sheer weight, 400 tons. And so, but they were measuring as they did before, measuring as much as they could, but with the traditional methods. So they didn't pick up these deformations. And it's only by bringing in more advanced technologies, when Argon was called in, we could actually make the invisible visible, and then try to solve it, and then try to prevent and for the future, and improve their processes so that they can avoid such things, and deliver better quality. So yeah, it's all about what we call shop floor measurement solutions. And the benefits of those solutions are speed. We make it, generally we can go up to 4 or 5 times faster than traditional methods. We are generally more accurate, we are safer, it's much easier, and you get more and more relevant data so that you can come to really fact-based decision making. So the building blocks really are, generally we have 5 building blocks of our solutions. It's about hardware, services, and software. The first 2 components are hardware, which is the measurement technology standard that we buy mostly from Hexagon. And then we have our own automated automation hardware and tooling. In this case, you see a trolley, you will see other examples. Then we, apart from as it comes to the software, we use also external software, Metrolog or SA, and we have our own smart interfaces, our own human-machine interface, which is very critical for a good, easy solution, and also the application scripts, which contain all the know-how of measuring and analyzing the data for a given niche application. And of course, with software and hardware, you're not creating a solution. You have to really offer a lot of services to implement it, to guide, to train, retrain, to optimize, and then also to support along the life cycle, the lifespan of the project. Support with new programming of new variants, support with yearly update training, support with small optimization services, and backup services, and so on, calibration, and then yes, together this then can delivers a solution that for the customer is really much more than the sum of its components. And if we look now concretely at what does that mean, let's go through some solutions that we developed for the sector step by step, starting from the blades over nacelle to towers and cranes. So let's start with cranes. Let's start with blades. So blades, the key challenges, or some of the key challenges there, are when it comes to product quality, it's really the wing geometry. When it comes to surface smoothness, the overall shape of the aerodynamic, the overall aerodynamic shape, that is really critical for turbine performance, critical for minimizing turbulences and vibrations. The root, also very important to make sure it's fixated well on the hub, recently, I saw some pictures in the news of a blade that really broke off. That is because probably it hasn't been made as precise as thought, and that fatigue pops up quicker, and in that way you get failure. So the flatness is important. A nice perpendicularity of the root on the blade axis is also important for avoiding imbalances. And there also precision, the more precise you produce, the more the less imbalances, the less vibration, and the higher performance you generate. Of course, also when you're producing these large components, when you're setting up the molds, when you're drilling the holes, there assistance is also needed to make. But you see, it's a trolley that's moving around the blade, and the root is at this moment still inspected tactile, but we're also working on non-contact next versions. So it is really about a trolley that is moving around 120 meter blade, going up to 8 meters height to measure the trailing edge, and it's all guided by a human machine interface on a tablet PC. A next component of a turbine is a critical component is the nacelle, where the generator forms the core of that part. And when you talk about generator, it's really the air gap that is very, very important determinator of the performance of the annual energy production of such a turbine. And so a 1 millimeter deviation from the optimal air gap leads really to a reduction of this annual performance. So it's really a challenge to produce these in a repeatable way with the optimal air gap. And that is something where we have helped Siemens significantly. And in doing so, we also created the first time right generator assembly process. So they gained in terms of production efficiency and in terms of product quality. And we have done this by measuring the rotor house and then doing the assembly of the stator based on the data from the rotor house to do a measurement assisted assembly. And going from the past manual 1 hour measurement time solution to a live tracking solution for this segment assembly. The rotor housing is measured in about 15 minutes. Also, again, you have more accuracy, you have less operator action, so it's safer, it's simple, and you get live results. You get the stator, the rotor housing geometry is used as input for the stator assembly. It is done with hexagon technology and also partly with other technologies such as a laser radar because of the precision that this device can deliver. So in the past it was done with photogrammetry. Now it is done with optical techniques that work much faster and give you live results and which are shown to the operator in this way. So you go from a slow, unintegrated manual user-dependent measurement system to a more integrated live system. To do such a project, such a huge project, over 7.5 million euro of invoicing for us over the past years. It's very complex. So we started from a white page in 2000 at the beginning of 2020. Now several of these solutions are in operation in Cuxhaven. Several sub solutions. They are in operation. We are doubling or we are copy pasting a solution in Denmark this year, and we started all from a white page. And of course, you cannot start a project in a traditional way of kickoff meeting, design review, FOT and SOT. We went through a process of carefully designed pre-studies where you start with a design, a first idea, worked out together with the customer. You do a demonstrator or demonstration. You learn from it, you discover things, and then you adjust and you do a new test, and you do some loops to come to to an understanding that all parties, supplier and client, we see, okay, this is these are the risks. We feel comfortable with it. We have them under control, and we are able to jointly define the specifications of the project and then implement the project. And this really has been very successful. And it also led to the creation of a partnership with a local Leuven-based Belgian company, a software development company. So we worked very closely together and created in this way the value for Siemens. And it really creates a unique way. It's a unique way of collaborating. They are a company a little bit larger than ours, but not a big company, but means very versatile, very agile. And it's really lots of workshops with post-its to come to fill in this white page and come to specifications that then can be implemented. So it was really it's not a normal client supplier-client relationship. It's really it's a partnership. It's really a very close. And this group of people, you see, these are people from the customer, people from Kunlabora, and people from Argon. So it's really a very nice collaboration. And in that way, it's also needed when you, as software as a critical component, when you implement such complex measurement-assisted production solutions. The next, apart from the blades, the nacelle, you also have the towers and the foundations. And there, what is critical there? It's really about the flatness, because these are towering up to 150 meters above sea level in the future. So you need the flatter your flanges are, the longer they will live, the larger the lifespan will be. 1 millimeter flatness tolerance is something that they ask. It's really on these huge structures is quite challenging. Ovality is also key to get it installed. And something less obvious, or something maybe obvious, is that just having the internal and external welded components in this tower and on the foundations, maybe they're not that you don't have millimeter tolerances, you have a couple of millimeters, but it's a question of ensuring the completeness, and that is a very big challenge for them. And that is, you will see later on how we have addressed it. And the marking of the welding for these external and internal and external secondary components is also a challenge to do that efficiently. Actually, the creation, the rolling of the cans, of the circular cans, each of such tower is made up of cans that are 2 meters high. And so one section of 30 meters is about 15 cans welded together to create one section. And that rolling process is also a challenge to make that more first time right and faster. So some of the solutions we have developed is from a very manual and contact solution. We went to a non-contact solution, a super easy non-contact flange inspection, where you have on-the-spot measurement results. Again, the Hexagon's solution, the ATS 600, is the key technology driver there. We can measure a flange in 10 minutes, more accurate, no lateral cherry picker, no training needed in metrology, and we deliver all the data that the customer needs. So here, this summarizes the difference. Here you have people, you need to put the person high up because he needs to put a device there. And in this case, you put the device in front of the flange and you press start. So it's a revolutionary, it's a change for this sector. It's quite revolutionary. It has a big impact. To give you an idea of how this looks in reality. So the first implementation that we did in the Benelux area, we did it with a client there in close collaboration. And you get a feel for what it means in reality. So it's a device, an ATS 600, being used for the inspection of these flanges when the pipe is lying horizontally, but sometimes also when they are vertically. So we measure in 10 to 20 minutes, depending on the date, on the extent. You get a human machine interface, a tablet PC, you have some specific toolings. And here you see the ATS doing his work, doing the scanning of holes or flatness. Of course, we also made a mobile kit to measure in up-ended position, 30 meters above the ground. And this is one solution that the customer can deploy on the ground to measure horizontal transition pieces or upended at 30 meters in the sky. So it's really setting new standards for both efficiency and also amount of data in this sector. So this is our flange scan solution. Next to flange scan, we also have weld scan. So the same system can be used not just for measuring flanges, but also for helping the company to mark the locations where you weld the secondary steel structures. So you mark them and then you inspect them afterwards. This is what I did before with the roller tape and a distometer, with the distance meter, a laser beam, but really manual. Now they get assisted by live guidance, thanks to the ATS. And this is a setup when after everything is welded, the ATS is being brought back into the tower, and you press start, and every component is scanned and inspected in that way. I'll show that to you in the video here. So with the same customer, this is also an example of how one investment is being used for various applications within the company. In this way, making sure that enough return on investment is created. So, of course, you can measure the geometry of the overall pipeline, of the overall pipe. You use that for alignment purposes as well. And you see here it's live tracking. This is an operator applying the system. It's a toolkit that we have created. And he is making the markings in the steel for the welders afterwards to weld the components. So you see it here. These are the markers. So up to 4 times faster. But we create 100% reliability. Why? Because afterwards we measure it also. We measure all the studs, the components, and you have a digital trace, a full traceability of the correctness of the tower. So that is the advantage of this solution. So so you have a full digital traceability, and it's also about new standards in reliability and efficiency in the sector. So and we are rolling these systems out now with other companies in Europe. And of course, it's not just about a sensor and some software. There's a lot of know-how that comes into play, because if you want to deal with millimeter or sub-millimeter accuracy and tolerances, you have to take into account that there's gravity. And when you measure a part that normally stands up-ended, it takes maybe a fairly circular shape. But when it's under gravity, this deformation can be up to or more than 100 millimeters. Also in the middle, if this is 30 meters, this can be, same order of magnitude. So you have a huge deformation, and you need to compensate for that. And you need to program and develop routines and test it to compensate for these gravity effects. So there's a lot of know-how that comes into play. It looks simple, but it isn't. Another application that we developed, I call it the mini application, has to do with the platforms of these transition pieces. These yellow pieces are called transition pieces, and basically it's not rocket science, but they have to weld these studs on it to place walking grids over it. So there's a couple of millimeters of tolerance, but still the challenge is to make sure that they are welded on the correct place, that they welded at all. And our customer says, well, or our customer said, okay, here sometimes we make a small mistake, but it has really big problems. So small issues, big problems, and that is why they were ready to invest in a solution that gives them peace of mind when they ship something, when they paint something and send it out for installation. It's not going to cause problems. So this is, we call it StopScan. It's a solution, again, based on an 8500, so not an ATS. So there's some more manual work involved. But yeah, so it gives them a methodology of quickly checking the positions of these studs and doing a correction when necessary. So basically, before they did just do a visual inspection, and now they do the inspection here. This is 8500 with a sort of adapter sleeve made for the inspection of the stops. Of course, this has to be put manually over each of the stops. So a last application to close my presentation and make some room for questions is crane scan. Crane scan, apart from the turbines, you need also cranes on the boats or on land with telescopic cranes to install them. And these also get bigger and bigger, and the challenges, they are faced with challenges. And the challenges are really creating the straightness of these tubes, making the tubes with very straight tubes. They are welded tubes. And also they have to weld secondary components, like for the towers, you have lots of secondary components, maybe not on millimeter accuracy, but they have to be there. If they're not there, they cause problems later on in the assembly process. So they need to be located more or less right, and they need to be complete. Again, the challenge also is how do you mark this? And when it comes to telescopic cranes, which extend up to 100 meters in height, how do you shim them correctly so that they are, instead of being a banana, they are a more nice straight line? And that is where we also have delivered solutions, particularly in the first instance for telescopic cranes. These are the monsters, big beasts that you see here, going up to 100 meters high, with all sorts of extensions. And we created a solution based on an ATS 600 to measure these pipes, tubes in a very quick way, and calculate also the assembly, the shimming parameters from these data to create a first time right assembly process later on. And this is also a solution with a big impact for customers. You see it here. This is how they measured it before with some jigs, with some calipers here as well. And now these are tools that cost €40. This is a tool that costs €400,000, but still the customer went for it because they saw the value. If they don't do it, if they continue the way they were working, they were unable to optimize their production. They were unable to guarantee the quality and improve the quality. So that was why they made this step and moved forward. To give you an idea of how this looks like, small video with the ATS. Okay, you see here ATS is scanning very quickly. This is a four times speed, of course. But so you work with different positions with a trolley. You move it around. You put it on some marked areas on the floor. This was in a prototype phase or in a testing phase. So it's not a final solution, but it shows you the gist of 3 positions and a trolley that is being moved around to quickly measure the pipe, and all the operator has to do is moving around the trolley and pressing with his finger on a touch screen on the trolley. So that brings me to the conclusion. So that of this presentation of metrology in wind, we see that in wind, every millimeter counts, even as the structures become much larger, the turbines become ever larger. And you have to make this invisible millimeter, you have to make it visible. And that is what we are aiming with these new technologies from Hexagon mainly. And we do this by empowering the operators, shop floor operators, with these advanced 3D inspection tools to make sure that they are as easy to use as a coffee machine. And this can be used for final inspection so that you have peace of mind when they ship them out towards the sea, or you can do that in production as a measurement assisted production solution. All the time delivering faster, more accurate, safer, simpler, and more relevant data. And that is what our business is at this moment, what we are very focused on. We see lots of opportunities. We're only getting started. And so it was a pleasure for me to share you some of the results of this journey. And I'm very, very happy to take your questions afterwards. Thank you.
Fantastic presentation. Thank you, Gert, for sharing and also naming it, that everyone understand what we are doing, or what you are doing with this solution. I think you put yourself really in the customer shoes and were listening very closely to what is required. Is there, I mean, the question was, is there a business case for it, and why it's not more widely shared and spread in the world?
Well, yeah, basically, you have two questions. So on the one hand, the business case. Indeed, it is true that when you go to a customer that is using a jig of 50 euro, 100 euro, and you tell him, and he says, I need a measurement, I need to measure more. And yeah, you tell him, oh, well, this is going to cost you 400,000 euro. Well, first, yeah, he's almost falling off his chair. So people do not expect these type of budgets. But when you take them, when you then together go through their needs, what is the value of this information that they're missing? Then you quickly see, well, the value is huge. If they continue with the low cost methods, they are not capturing that value. So in the end, all of these companies, they make the decision, they do the maths, and often we have to say, well, okay, let's make sure that you can also measure other things to improve the business case. Of course, I must say, generally the business case, in some cases it can be less than a year. In some cases it's 2 to 3 years. There's it's then more a strategic business case. But generally we see that if they don't get the millimeter right, or they make mistakes and they ship non-quality to the sea, the impacts are huge. So that is why a simple stud, people are willing to pay 200,000 euro for a solution to measure a stud. You would say, oh, you would be amazed. But this is the cost of non-quality is so high that creates the business case. So that is one answer to your first question. The second question is, well, why hasn't it been on the market earlier? I think basically it means that I showed you the slide of the 5 components. So the first 2 components, the Hexagon system, a measurement device, then the automation hardware, then the software, measurement software, and the scripts, and the 3DMA, and the services. So you need to have all these 5 components. Just one component, purely a tracker, you will never sell a tracker for such solutions on its own. It needs to be a solution. You will never sell a software on its own. So people are looking for a solution. And for some reason, I think in the wind sector, Siemens Gamesa, they ordered large amount of money from Argon over the past years. And of course, their purchasing department has made an effort to find alternatives for us. And in the end, we don't find them yet. So there aren't many people doing what we do to take these 5 building blocks and create a solution out of it. And I think that is why at this moment we are fairly unique in what we do. Of course, you have other companies doing this in maybe in automotive or in aerospace, but in wind, this is measurements as a relatively new activity, and this so this is not yet existing, and that is a gap that we have identified, and where we are really putting all our energy into to focus on this and becoming a leader in this area.
One question was, all of these cases you presented, Gert, were in the manufacturing stage. Are these solutions also usable in a in-service inspection of wind turbine?
Well, service inspection as a metrology service. So sometimes we are asked just to do a service, a one-off inspection, and then we use these scripts and 3DMA and so on, and the toolings to do the measurements very quickly. But this is all in a manufacturing environment, all onshore. At this moment, the offshore, once the turbine is installed, we really haven't, we are not, we are exploring, but at this stage, because of the situation, at this stage we haven't really found the niche applications yet there, and partly because offshore, you don't have the to measure in a millimeter on things that are moving and wind and so on. It's a huge challenge. So that is why onshore things are lying on the floor; they are not moving. That is something easier to make a millimeter visible than when it's even moving around. Then it's a moving target. So, but I know the installation also, there's challenges during installation. But so as we go deeper and deeper into the sector, and we are allowed into the internal kitchens of these companies, we will sooner or later also start to identify opportunities there. But at this moment, it's purely in the manufacturing. It's on land.
And then there are questions about orient to gravity. Can the ATS 600 be used for orient to gravity? And there is a nivel inside, so yes, you can use it for orient to gravity. And then there's a question about USMN, so a kind of network feature of special analyzer. So it seems that we have here a special analyzer expert in the call. Is this also available in other softwares than special analyzer?
Well, we use very much Metrolog as a platform in which to program. I'm not the expert. I would have to ask, but we also work with networks. The efficient relocation is a huge focus area of us. We are doing some research on that to improve that. I think Metrolog, I don't think that at this moment we use any of these algorithms. So we have developed our own way of relocation. So that is but relocation and fast relocation is critical, because you can imagine with the blades we have to move around the trolley, the measurement vehicle, in about 15 positions over a period, over a span of 100 meters. So finding your nests in a quick way, automatic way, is a challenge, and we have cracked that challenge. But the US MN functionality and how it compares to what we use at this moment, I would have to check with my experts. So I cannot not answer that directly now. Yeah. But I can get back on that.
Yeah, thank you. You are a fairly small company in Europe, in Belgium.
Correct.
What happens if we have here in the audience someone from US and Asia? Can they make use of of Argon as well?
Absolutely. So that is why we developed what we call name scans. And these are these standardized, you could say productized solutions for specific niche applications, which we then can roll out also overseas. So in the US or in Asia, we work with a local Hexagon partner to, if the sensor needs to get calibrated, that is done locally. We will certainly go once a year on site to update and train and check the system. We use the latest tools on the market for remote intervention. So we can take over the screen most often via TeamViewer or via systems like TeamViewer to assist the operators. We have service level agreements that we have a given reaction time. We have uptime guarantees, so we can. Yes, we have at this moment also solutions. In the US that we support. We have a solution in India. So yes, our vision and our ambition is clearly to do this together with our partners, like Hexagon, to do this, to roll these solutions out in a standardized way worldwide.
Mm-hmm. And I see you're as Argon, you're like you have the advantage of being very flexible. So you shift your business to wind energy, for example. But how you dominate or how you work with big companies like Siemens Gamesa and GE and Hexagon?
Well, it's I think indeed the fact that we got through Siemens Gamesa via Hexagon. We got to Element via Nikon. As these companies will not find us ourselves, but now we are developing because we are now so niche. We start finding. It's not a big world. We start finding our way. And because of the track record that we managed to build up with some companies, you can use that to convince the other company. And because of also the project management approach that we have developed, we have been able to win the trust of these companies, and that we can say, well, despite our size, we can be a reliable partner for these niche applications. And it goes so far that as I said, I'm currently in Denmark, in Aalborg, and we are doing a project where Siemens really insists on buying the measurement solution directly from Argon rather than Argon supplying to a larger integrator, because they see that by working directly with us, we can better respond to their needs. So once you build up the name in this niche application and in this niche field, we feel that the trust that you gain with one application with one customer, you can copy paste it to the others, and from there onwards we feel we can have a growth. We will not go to 100 people, but we will certainly have a stronger growth in the coming years than we had over the past.
There is one interesting question. In the end, I will ask, will this automation solution eliminate the human involvement and cause the losing jobs of people? And I think we automate because we cannot find the people. What is your opinion?
Yes, I think all the people, even in India or in companies in Europe or in India or other in Americas. I think in Europe we are dealing with an aging population. We have people from all over the world coming to Europe, but overall the aging population means that there's skills retiring. So overall there's a huge shortage of skills. So in India they may have more people, but also the skill level is not high. So overall, all the companies, wherever they operate in the world, they have a challenge to get skilled people. So if you can deliver a solution that de-skill the need, that say, well, you don't have to have expert metrologists or expert inspectors to operate the system. You can just have anybody who can, so to speak, read and write, operate the system. That is an enormous advantage. So in this way, we respond to global trends of shortage of skilled people, but because of the so you will, because of the fact that you cannot let it be done by robots, you will always have people. You will always need people. Maybe not as much as before. You saw that some in the past a flange inspection was done with 2-3 people, and in the future, maybe done by one person. But for example, in India, our solution will be used also still by 3 people, but the manager knows, okay, the results will be good. So what we see, the blade scan in India, it is not eliminating jobs, but it's just securing that what these people are doing, that it has value and that it is reliable. So I think it is. My feeling is that it is not really replacing jobs. It is just securing. It's empowering the people that work currently. That is how I see it, and it is responding to the fact that the people that are employed, generally the challenge is to equip them with the sufficient skills. And if you can then develop tools that are less, that do a de-skilling, that is an advantage.
Okay, so I think we are done with the timing. So we stop here. I would like to thank you again, Gert. And if there are more questions, and I still see some open questions, we will take them separate. Please don't hesitate. And I see you also have your QR code of your LinkedIn account here. Thanks for sharing. I would encourage everyone who's listening, also from the recording, please scan this QR code and reach directly to Gert or to Thomas Schmidt. You will find also my account somewhere. So thanks, thanks Argon,
Pleasure.
thanks Gert, and thanks for your participation and your questions. Thank you very much.
Thank you.
Bye-bye.
Bye-bye.